Hello. Once again, you are welcome to our SHS 3 Core Mathematics lesson brought to you by the Center for National Distance Learning and Open Schooling. I am Lucia Sari Nelson. The topic for my presentation today is geometric construction. We take the third and final lesson on geometric construction. By the end of this lesson, you should be able to A. Construct a loci, and then B. Solve examination questions. A locus is a set of all points whose location satisfies one or more specified conditions. The plural of locus is loci. Let's see some examples of loci. 1. Locus of points equidistant from one fixed point. Let's see the method of constructing such a locus. Using the point as the center and the given distance as the radius, construct a circle. The locus is the circle. Let's take an example. Consider the triangle shown. Construct the locus P of points 5 centimeters from A. Let's look at the solution. Open your compass and measure a length of 5 centimeters. And using the point A as a center, construct a circle like this. Good. The constructed circle is the locus. 2. Let's see how we can construct the locus of points equidistant from two fixed points. Here is the method. Construct a perpendicular bisector of the line segment joining the 2 points. The locus is the perpendicular bisector. Let's take an example. Example 2. Consider this triangle. Construct the locus M of points equidistant from A and B. Let's take the solution. We are going to take the point A. With our compass point at A, we'll scribe an arc up and down the line AB. Now the line M gives that locus. 3. Locus of points equidistant from 3 fixed points. How do we construct the locus of points equidistant from 3 fixed points? Let's look at the method. 1. First join the 3 points to obtain a triangle. 2. Construct the perpendicular bisector of any 2 sides of the triangle. 3. The intersection of the 2 perpendicular bisectors is the locus. I want you to note that this locus is a single point called the circumcenter. This point can be used to construct a circumscribed circle. Good. Example 3. Consider this triangle. Find the point O, equidistant from A, B, and C. Let's take the solution. We first construct the perpendicular bisector of any of the 2 sides. Let's choose side AB and side AC. Let's first construct the bisector of line AB. Next, we'll construct the bisector of line AC. The intersection of the two perpendicular bisectors is the locus. Good. Just as we can construct the locus of points equidistant from points, we can also construct the locus of points equidistant from lines. So let's look at the fourth one, the locus of points equidistant from one line. To construct the locus of points equidistant from one line, step 1, construct parallel lines above and below the required line. Step 2, with the same radius that you use to construct the parallel lines, construct an arc at each end of the parallel lines to complete the construction. The running track obtained is the locus. Good. Now that we have constructed the locus of points equidistant from one line, let's see how we can construct the locus of points equidistant from two intersecting lines. Here is the method. Bisect the angle of intersection of the two lines. The locus is the line dividing the angle. Let's take example 5. Consider the following diagram. It is a quadrilateral. Construct the locus T of points equidistant from RS and PS. Let's take the solution. The point of intersection of the lines RS and PS is S. We construct a bisector of the angle at S to obtain that line. Good. We can also construct the locus of points equidistant from sides of a triangle. Here is the method. 1. Construct a bisector of any two of the angles. 2. Locate the point of intersection of the loci. In the previous step, as the answer. The locus is a single point in this case also. Example 6 would explain that. Consider the triangle shown. Locate a point O inside triangle PQR, which is equidistant from the length PQ, the length QR, and the length PR. Let's take the solution of that. We will first pick any of the internal angles of the triangle and construct its bisector. Let's use angle PQR. In angle PQR, the angle to be constructed is at Q. And so we are going to bisect angle Q. Next, we construct a bisector of any of the two remaining angles. Let's choose R, the angle at R. This means that we bisected the angle QRP. And then we have joined the two loci to get a single point. This point is the locus we are talking about. Good. Now let's see how we can construct a perpendicular from a point, an external point, onto a line. Let's take the steps. Step 1. Open the compass to the distance more than the perpendicular distance from the point O to the line. 2. Draw an arc to intersect the line at 2 points X and Y as shown. 3. With the compass point at X and using the radius of the length OX, draw an arc on the other side of the line. 4. With the compass point at Y and using the same radius as used in step 3, draw an arc to intersect the one drawn in step 3 at Z. Step 5. Join the points O and Z with a straight line. And that gives you the required construction. Now let us apply our knowledge on loci to solving examination questions. Let's take the first one. In fact, if you have come this far, it means you can solve any examination question. So this is example 7. Using a ruler and a pair of compasses only, construct a quadrilateral ABCD such that the length AB is equal to the length BC and is equal to 11 centimeters. The length AD is equal to 7.5 centimeters and angle ABC is equal to 105 degrees. Also, AD is parallel to BC. BI. Construct the locus M of points equidistant from the length AD and the length CD. II. Draw a perpendicular from C to meet M at O. CI. Measure the length CD. II. Write down the name of the quadrilateral ABCD. III. Calculate the perimeter of ABCD. Correct your answer to 2 significant figures. Let's take the solution. A. We first construct the line AB of length 11 centimeters. Next, we construct angle 105 degrees at B, since we are told that angle ABC is 105 degrees. Now, since the length BC is parallel to the length AD, we construct angle 75 degrees at A. That is from the properties of parallel lines, co-interior angles add up to 180 degrees. We then indicate D, which is 7.5 centimeters from A. Again, we will indicate the point C, which is 11 centimeters from B, and join points D and C with a straight line. After this, we will construct the locus M equidistant from the length BC and CD. Now, since the two lines meet at C, we will bisect the internal angle BCD. We will complete the construction with a perpendicular from C to meet line M at 90 degrees. Good. Now let's take the C. I. We are to measure the length CD. As per this construction, the length CD is equal to 12.4 centimeters. And II, the quadrilateral ABCD, is a trapezium. This is because a pair of opposite sides are parallel and unequal. III. Let's take the perimeter. The perimeter is when we add all the sides, when we take the sum of the sides. So the perimeter is equal to 11 centimeters plus 11 centimeters plus 7.5 centimeters plus the length CD, which we have to measure from our construction. So that will give us 29.5 plus 12.4, which is equal to 41.9. So to two significant figures, our answer would be 42 centimeters. Therefore, the perimeter is 42 centimeters. Good. I want us to take example 8. Using a ruler and a pair of compasses only, construct a parallelogram PQRS such that the length PQ is equal to 8 centimeters, the length QR is equal to 6 centimeters, and the length PR is equal to 11.5 centimeters. B. Construct the locus U 5 centimeters from Q. C. Construct the locus of points T equidistant from the length PS and length SR. D. Indicate the points of intersection of U and T as A and B. Let's take the solution. First, we will construct triangle PQR, which is a triangle with all sides given. Next, we want to locate the vertex of the parallelogram and open your compass to a distance of 8 centimeters, and with a compass point at R, scribe an arc. This arc should be in line with the length PQ. Again, with your compass point open to a distance of 6 centimeters, and with the compass point at P, scribe an arc to intersect the previous one. Indicate the point of intersection of the two arcs as S. Finally, join P and S, R and S with straight lines to complete the construction. Good. We then construct the locus 5 centimeters from Q. This means using Q as our center, we will construct a circle with radius 5 centimeters. Good. The next thing we want to do, as per our question, is to construct the locus of points equidistant from the length PS and the length SR. This is the bisector of the angle PSR. We then indicate the points of intersection of the loci U and T as A and B. That will help us complete the construction. Good. I hope you were able to come along with me. Example 9. Using a ruler and a pair of compasses only, construct triangle ABC such that the length AC is equal to 9 centimeters, angle BAC is equal to 105 degrees, and the length AB is equal to 8 centimeters. That is A. B. Locate a point O inside triangle ABC, which is equidistant from the length AB, the length BC, and the length AC. C. Construct a perpendicular from O to meet the length AC at D. D. Using the length OD as radius, construct a circle with center O. Good. Let's take the solution. We construct the triangle using the method discussed earlier on. This is a triangle with two sides and an angle given. So this gives the triangle, as you can see. Now B, the B part of the question. The question is demanding a locus equidistant from 3 sides of the triangle. So we construct a bisector of any 2 of its internal angles, and preferably let's take the angle at A and that at C, and that will give you what you can see on your screens. Now C, we will construct a perpendicular from point O to meet the line AC at D, like this. Then we move to D. With your compass point at O and using the radius of the length OD, construct a circle like this. And that ends the construction for this question. Well, I hope you have followed this lesson from lesson 1 till now. And I hope you can now construct your angles, construct your loci. We have to end it here. But let's take a quick look at what we have done in this lesson. In this lesson, we have learned how to construct locus of points equidistant from a single point, 2 points, and 3 points. We have also learned how to construct the locus of points equidistant from one line and 2 intersecting lines, as well as 3 intersecting lines. Aside these, we learned how to construct a perpendicular from an external point to a line. Construction of most loci heavily depends on the knowledge of angles and line bisectors. The locus of points can either be a circle, a line, or a single point, and as we saw in one case, even a running track. It might also be the combination of any of the 4 outcomes. Well, students, we have come to the end of yet another lesson. In our next lesson, we would look at mensuration 2. Join us again as we take you through mensuration 2, all the lessons that we will have in mensuration 2. Until then, it's goodbye.